You might have heard that we're running out of fresh water. This might sound strange to you because if you live in a place where water flows freely from the tap or shower at any time, it sure doesn't seem like a big deal. It's just there, right? Wrong. The only obvious thing about fresh water is how much we need it. Because it's essential to life, we need to think about it carefully. Right now, at this very moment, some people, women and girls in particular, walk hours and miles per day to get fresh water. And even then, it may not be clean. Every 15 seconds, a child dies due to waterborne diseases. This is tragic. The most compelling reasons to think about fresh water therefore have to do with what we might call the global common good. This is not something we normally think about, but it means recognizing how much fresh water matters for the flourishing of human and non-human life on Earth, now and in the future.
Assalamualaikum and very good day. My name is Muhammad Shamsa Hassan bin Hashim. My ID number is TC18030.
My name is Siti Nonajwa binti Ibrahim, TC18036, and our supervisor name is Associate Dr. Azrina binti Abdul Aziz. We will present our Senior Design Project 2 titled Treatment and Recycling of Water Ablution for Irrigation Purpose. As for our research background, water authorities realize the importance of balancing demand, so we need to secure the future water supplies. The water quality needs a deeper understanding on how water is used and stored. Around 3 to 7 liters per percent of amount of water used in ablution a day. Therefore, the global needs to extend the pipelines, build new dams, change the method of storage, as well as the recycling water. Globally, demand of fresh water has risen exponentially in a number of countries. From the research, we know that water pollution are one of the causes of lack water sources in a country. So, another recycling method that we can do is recycle the grey water from ablution that have been performed by Muslims. After that, the recycled water ablution can be reused for plants watering at UMP nursery.
For the research background, we have come out a few problem statements that focus on our research study. So, for the first problem is, we found out that the water pollution is one of the major environmental problems faced. The next one is, for the second problem, that we found out that the water wastage comes from the ablution water at UMP almost and the dependence of the nursery plant on the clean water supply from the UMP most. Then the other problems is the current prayer facility design, which is the pipeline from the ablution area was directly discharged to the drain without any treatment. Therefore, the problems that we found out, we aim to study the characteristic of water in UMP Gambang Mosque. And then after study the characteristic of water, we design and fabricate the filtration system and the aqueduct system for irrigation plant. And then we evaluate the performance of the aqueduct system by determining the water characteristic.
Next, the scope of research for this project, the ablution water samples that have been collected are treated for total dissolved solid TDS, total suspended solid TSS, turbidity, chemical oxygen demand COD, and pH. After that, the current research was carried out with the goal of developing a workable model of the system, which is EcoWudu. The development of the EcoWudu was created by using AutoCAD specifically for the pipes and fitting in ablution area. In this study also being studied the characteristic of water after the treatment by using the EcoWudu system.
The significance of the research is that the aqueduct is the alternative system that can save the consumption of the fresh water, and it also can increase the awareness about the importance of the recycling the water. Then, the recycled water can addressing the water shortage issue. Lastly, we are able to use the recycled water from the UMP mosque for irrigation in the nursery plant.
Water is important. Therefore, we need the management strategies for the household water and then introduce the smart water metering. The water consumption in Malaysia is needed for urban, suburban and rural area. The main properties of household water is including biochemical oxygen demand BOD, chemical oxygen demand COD, ammoniacal nitrogen NH3 and heavy metal and pH. Usually, For the current water treatment that used by community water system as per picture, the system is started from coagulation, sedimentation, filtration, disinfection, and the last one is storage. This is the water conservation strategy. This rainwater harvesting is one of the strategies that have been researched for and can help to prevent the wastage of water and also reducing irrigation losses. From this water use strategy, the water can be used for irrigation, residential uses, urban and recreational uses, and also for aquaculture. Next is for research methodology. Firstly, I would like to explain the flowchart of this project, starting with carry out the study location, which is at UMP Gambang Mos from inside view and outside view. Then, study the sampling location where the greywater discharge outlet of the mos. After that, we analyze the characteristic of greywater discharge in 5 parameters such as total dissolved solid, turbidity, total suspended solid, chemical oxygen demand, and pH. We also design a small-scale filtration system using AutoCAD design, and then fabricate a small-scale eco-wuduk system and test run on it. After that, finalize the eco-wuduk system and then treat the ablution water using eco-wuduk system.
For the sampling location, the study was located in UMP Gambang Mos. In this study, we had take 3 locations for water sampling study. Location E is at the back of the UMP Mos, location B at the in front of the UMP Mos, and location C is near the ablution area drainage. The reason why we take the 3 locations is we want to make sure that all the ablution water is fully tested and fully treated. In this project, we carry out a characteristic study of the total dissolved solid, turbidity, total suspended solid, chemical oxygen demand, and pH. Then, to ensure that the good quality of recycled water, the used ablution water should be treated through the sand filter with a sand media having the effective size ranging between 0.3 to 1.0 mm, and the uniformity coefficient should be ranged between 1.3 and 1.7 mm. Then, the sand was sieved to determine the effective size and the uniformity coefficient. For this clean river sand, we determined that the effective size was 0.45 mm and the uniformity coefficient was 1.51 mm. For the sand filter, we used 2 cm thick gravel layer 1, which size 0.4 to 0.6, then 12 cm of clean river sand that have been sieved before, 4 cm of thick gravel layer 2, which size 0.1 to 0.3 cm, and 4 cm thick stone layer size 0.5 to 0.1 cm at the bottom. Size of the sand filter was determined based on the allowable overflow rate, which is 39.1 meter cube per day. This value falls within the range of solo sand filter, which is 2.9 to 7.6 meter cube per day, and the rapid sand filter is 120 to 235 meter cube per day. However, it was realized that the sand filter to clean the used ablution water with a target to use for landscaping can be operated as slow sand filter to minimize its maintenance frequency. For this sand filter, its filtration rate was 52.21 meter cube per meter square per hour. It concluded that it is a low rate and has a very good filtration but required a very large surface area. Slow sand filtration systems are characterized by a high reliability and rather low life cycle cost. Moreover, neither construction nor operation and maintenance require more than basic skills. Hence, slow sand filtration is a promising filtration method for a small to medium-sized rural communities with a fairly good qualities of the initial surface water source. As stated by the WHO, slow sand filtration provides a simple but highly effective and considerable cheap tool that can contribute to a sustainable water management system. This model uses closed-loop system that has the advantage of minimizing water wastage via greywater discharge and prevent the contamination from the external source. It starts with the water was collected in the collection tank, and then the water will flow into the sand filter for removing fine particles before channeling it into the retention tank. The use of the retention tank is to give a support to the water supply if the water at the distribution tank is dropped. In this part, we also use the Arduino control water pump to make sure that the water at the distribution tank always enough to supply the clean water. No technical abnormalities were found during the test run of the small-scale model apart of the minor hose leakage. This issue was quickly resolved using the stronger silicone glue. Now we see how it works.
For the result, this table shows the data that has been collected from the measurement of ablution water samples in terms of 5 parameters for before and after filtration. The values of the result show difference of the data for before and after filtration which are decreasing. It is proof that the sand filter was be able to filter the ablution water samples. It was also observed that the mean values of the parameters were lower than the Ministry of Health MOH standard for drinking water quality in Malaysia. However, it does not necessarily indicate that the treated ablution water is suitable for potable usage because the chemical oxygen demand COD does not available in the standard. In this research, it is more focusing for irrigation and other purpose.
For the graph, you can see here, this is the graph for turbidity. It shows the decreasing polar from before filtration and after filtration for 3 different samples collected, as well as for this chemical oxygen demand graph, TSS graph, TDS graph, and also this graph for pH. For the conclusion, the characteristic of water for this study by using turbidity, COD, TSS, TDS, and pH have the decreasing polar. We also successfully design and fabricate the small scale of eco-wuduk system. From the test, the result of the 5 parameters tested are fulfilling the Ministry of Health standard.
For the future recommendation, we can do the upscale of eco-wuduk system and it can be installed and used at the UMP Gambang Mosque. Then, the grey water can also collect from the rain harvesting as a source of eco-wuduk for non-potable application. I think that's all from us. Thank you.